Okay, so let's look at another example over here. And once again, we're given a standard normal distribution and 0, 1. And I'm going to go ahead and draw a bell curve right here. And this bell curve has center at 0 with standard deviation 1. And now the question I'm looking at is here. I would like to find the probability where my z-score is being about less than or equals to negative 1.05. But on the other hand, or looking for z-score greater than or equals to the 1.25. So first of all, let's understand how we put down the shading first of all. So shading is extremely important in this problem. Negative 1.05 is somewhere to the left-hand side of the center. Negative 1.05. And this statement says we are looking for the less than or equals to negative 1.05. So here's how I'm making my shading. Just directly from what we saw in the statements. We're looking for less than or equal to negative 1.05. But then on the other hand, or we're looking for above, meaning we're expanding our possibility to include as well those values being to the right hand side of 1.25. And of course these are all the z-scores or z-values on this bell curve right here. And so now this picture over here, immediately after we successfully made a sketch, then usually I refer to this when I'm meeting with my students face to face. I refer to this in my own term as this is the kind of problem where we run into disconnected areas. So what I mean is being disconnected areas here is because looking at the entire picture here, we have a piece of area here, we have a piece of area there, and all that. And so allow me to give the explanation and the approach to this problem being the easiest to understand, but not necessarily the fastest solution. But anytime, and we actually have seen some of this back in the days that we were doing empirical rules as well. And so anytime you run into this connected area, all you have to do is there's only one fundamental. Find all individual pieces. So here we got 2 individual pieces, and just find all of them. So find all individual pieces and total them up. That's only one fundamental anytime that we have to handle a problem with disconnected areas like this. And so, and once we draw down the area, it also, once we made a sketch of the area, it gave us a tremendous advantage here, because any of these, if we are thinking of doing any of these area here separately, then we already had a method, a solution to how to handle each one of these. So I can just briefly remind you, this area here is already being completely to the left-hand side of negative 0.01. And so we can find that area easily by running a technology resource right here. And I can use my LSND program to run that. And so negative 1.05, and my area there is being 0.1468591. Okay. And then this area actually appears to be to the right hand side of this given z-score here, and we already had examples showing how to find the area to the right hand side of a given z-score. And so what we do here is simply once again find the area cumulatively to the left of 1.25, but subtract that area from 1. And so here once again 1.25 in my LS&D program. 1.25 coming out from my LS&D program gives me the area here as being 0.8943 502. But keep in mind, this is not our answer for this little area here. We need to subtract that from 1, and that's how we can obtain. So all that area here is the area to the right little tail right here on that. And so putting the two pieces together, we found the area, see, and that's what I said. We find all individual, we found all individual pieces, and now we're about to total them up. And so the left side individual piece is being 0.1468591, and the right hand side piece is 1 minus 0.894350. Actually 502, I should have mentioned that. It was in front of me the whole time. And add them up. And so now final calculation comes out to be 0.2525089. Okay, that's in as far as possible in my precision here in 7 decimals, and it's that much. But like I said again, be aware that a lot of your assignments throughout textbooks or the online web assignments then can be asking for different various rounding for that. So be watching out for those. Requirements there. So as a 4 decimal places, then it's 0.2525 or equivalent to it takes about 25%, 25.25%. Of z-score staying either below this negative 1.05 or above that 1.25. All right, and so let's try again the same kind of problem with a different question. And so we're looking at find the probability of about z is being less than 0.8 or z is greater than or equals to 2.15. So once again, immediately after writing down the question right here, let's just go ahead and put up a sketch for ourselves right here. So 0.8 is here. 2.15 is about here, okay, and no need to worry too much about scaling, okay? But as far as the shading, okay, so on one hand I'm looking for less than 0.8, so that's producing this area cumulatively to the left hand side, but then or I'm also considering those z-score greater than or equals to 2.15. So that means outside of this area, I'm including those other areas. I'm expanding possibilities to include those z-score being above 2.15. Yeah. And so now, once again, what we have here is another similar situation as in earlier problem. We're looking at disconnected areas. Okay, so once you start feeling comfortable with the bell curve, working on the bell curve, I highly recommend if you can start doing this on your own before and finish that before I proceed to the end of my answer here. So individually speaking, this piece to the left hand side once again is quite direct. We can just look it up using any technology. My LS&D program is going to give me now 0.8 for the z-score, and I'm gonna just hit enter. My LS&D program gives me this area here being 0.788 1446, and this area here came directly out from the using technology resource right here. Now, this other area here to the right-hand side of 2.15, then remind yourself again with the left area concept, and any z-score from where it stands has an area to the left. So LSND or a lot of technology resources can give us the area to the left of this value. So 2.15 in my own program that I wrote is 2.15, gives me this area to the left being 0.98 for 2224. But this area is the area, the big area to the left of 2.15. It's not the area of the little tail here. So remind yourself in previous examples we have done, we're going to need to subtract this from 1 right here. And so now, and remember the ideas, and allow me not to write it down again, but we have to find anytime we're finding disconnected areas, it's the idea, that's what it is, we're accumulating area. And so we're going to have to find all individual pieces. So here's the area, how we find the area for this left piece, and here's how we find the area for this right piece right here. This is one area. And then total up all the pieces together. And so putting it all together, I'm looking at 0.7881446, and I'm adding with the other right-hand side piece being 1 minus 0.98422224. Okay, and so now I'm ready for a final calculation. Final calculation comes out being 0.8039222. Okay, and once again, if we have to put that in the 4 decimal places, then this is about 0.8039. Okay, that's another way that's quite commonly happen. And as an interpretation, it takes about 80.39% of times data falls below 0.8 or above 2.15 right here. Okay, so as a concluded generality about the type of problem we just solved, then generally speaking, we have a z-score low and we have a z-score high. Okay. And we got a z-score in the low end, we got a z-score in the high end. However, the area we're looking at are actually disconnected areas where one of them is to the left of the lower z-score and the other one is to the right-hand side of the higher z-score. And so, symbolically, the question stated as find a probability where z is less than or equal to a, the low end, or on the other hand, we can find, we also including those cases where z-score is being greater than or equals b, like that. So that's the symbolic description of the question itself. And then I use that term about, and it's actually pretty much my own term for this kind of problem, but here we refer to that as we're looking at disconnected we're having disconnected areas. Okay, and so really there are quite many different ways of how to approach this. So I just point out that the easiest way to understand now is that just find all and that's sort of like a planning instead of being a method right here, but we are finding all individual pieces and total them up. That's all it needs. And so I highly recommend that anyone doing these kind of problems then start pushing your creativity as far as you can. So my way of doing that is not the only way, and it's not the fastest way. It's not the fastest way, definitely. It's just simply the easiest way that that reflects the concept of accumulating areas. However, you can also think as a little bit of hint here. You can think of these disconnected areas as those areas being outside of our interval. So one way you can calculate inside of that intervals and subtract out from 1. That's also another way of handling it. And there are still many other ways of getting that answers.